Okay, time to get started. We've got a small group here today. We're going to talk about Linux running on Hyper-V. We're going to talk about FreeBSD running on Hyper-V. I'm Michael Kelly, and Jason Anderson here is going to join us for the last 5 or 10 minutes and talk about FreeBSD, focus on that. So I've got my Linux sign. Also, we've got some T-shirts here. Microsoft loves Linux. We're giving some of those out in the booth down on the show floor, but we're done with that now, so we're going to give out a couple of 3 of those at the end of this session as well. And given that you got a small group here, your chance of winning is very good. So pay attention. We're going to ask a couple of trivia questions after the session, and Anurag is going to do that for us. From an agenda standpoint, just going to talk a little bit about what we're trying to accomplish with Linux running on Hyper-V, give you an overview of the Linux and FreeBSD integration services. Want to talk about how that applies to individual Linux distros. You know, what distros can you run on Hyper-V? How do you get the Linux integration services there? Then we're going to dive into some of the specific features, capabilities that you get when running Linux on Hyper-V. I'll do a demo of what some of those features look like, and then some hints and some tips. There's a few things to be aware of, things that we answer questions on quite frequently. Jason will then pick up with a brief overview of where we stand with FreeBSD and where we're headed there. So this session, we've had a lot of different sessions here at Ignite that have talked about some of the future stuff that's going on, the 2016 releases of Windows Server and Hyper-V and System Center and so forth. This session is going to be almost completely about stuff that's available today with the 2012 R2 release. I am going to do my demos with the technical preview so that I can show a couple of things that are new that are coming, but I'll call those out. So most everything we're talking about here is what's available today. And obviously, the focus here is pretty much on premises. Hyper-V, of course, is the foundation for what runs in Azure, but the orientation of what I talk about here is going to be, in your data center, running on premises, as opposed to out in the public cloud. I'm presuming most people have seen this slide already. We're really had this mindset shift within Microsoft that leads us to trying to work really hard to make Linux a first-class citizen when running on Hyper-V. And, the Hyper-V guys are bugging me now, wanting to make, when are we going to get this particular capability added into the Linux drivers? Because they're feeling the pressure, they're feeling the input from customers of, let's really make sure that Linux runs well on Hyper-V. Let's make sure FreeBSD runs on Hyper-V. So this is a change. This is a real change within Microsoft over the last year or two. And I've been doing it, Linux stuff, at Microsoft for longer than that. So really ramped up in that space. This is the slide, of course, that Satya Nadella put up with some press and analysts back last fall, and has, I feel free to use the slide now. If you were by the booth, you saw we had stickers and buttons and so on and so forth. And I think it really does reflect quite well the mindset change that has happened within Microsoft. So from a product goals standpoint, the reality is your data center is heterogeneous. You run Windows, you run Linux. Some of you are still running some Unix operating systems as well. And so from a Microsoft standpoint, we want to make sure that you can operate those workloads on Hyper-V, that you don't have to bifurcate your world, run the Windows guys over here, run the Linux workloads over here. You just want it all to work. And we've had a number of customers that have been successful in deploying Linux, deploying Windows into their Hyper-V infrastructure, and running it as a single unified infrastructure. And so that you get the great functionality, you get the great performance. And this is the foundation for the private cloud, whether that's on premises, and then all of the work that we're doing here, again, also plays into the public cloud in terms of what we're doing with Azure. So, from a Microsoft standpoint, the operating system wars, we're not fighting those wars anymore. You're not fighting those wars. We just want to make sure that Linux works as well as Windows does. So that's the top-level goal of what we're trying to accomplish here. If we look broadly at, what's the functionality that you need to run Linux on Hyper-V? There's a great deal of functionality. In fact, most of the functionality doesn't really depend upon what the guest operating system is. So if you've been to other sessions about Hyper-V at Ignite so far, talking about storage improvements around quality of service, you've talked about RDMA to do live migrations really fast. We've talked about software-defined networking. all of that stuff works. It works for Linux as well as it works for Windows. And from an engineering standpoint, yes, we're making sure that it works for Windows, works for Linux as well as it works for Windows. And so there's a great deal of that functionality, and in fact, most of the functionality that really isn't dependent upon the particular Linux OS that's running, or whether it's Windows or FreeBSD or whatever. And so there have been a bunch of other sessions that have talked about that functionality. This session, we're going to focus on the areas where there actually is some dependency on the Linux guest operating system, where we do need to interact with that guest, and some of the enhanced management functionality. Dynamic memory certainly involves what's happening in the guest operating system, some of the live backup. So those are the things that we're going to talk about in this session. So all of that stuff up there, that just works for Linux and FreeBSD. Don't have to do anything special for it. We're going to focus on this session in terms of the functionality that requires that guest cooperation, and we'll kind of delve into the details of how that works at a technical level. One of the interesting questions that I get surprisingly frequently, and that I heard again today at the conference, was exactly what guest operating systems can I run on Hyper-V, and what's the fundamental requirements to do that? And there is this fundamental requirement that it runs on x86, x64 architecture, Intel architecture. I have questions, and it came up again this morning, of can I run AIX on Hyper-V? Can I run AIX in Azure? And perhaps that's a natural question to ask. For me, as sort of a computer geek kind of a guy, I think, wait a minute, AIX, that's PowerPC chipset. That's what it runs on. This is Intel architecture. No, AIX is not going to run on Hyper-V. And so that's sort of this fundamental question of, is that operating system built for x86, x64? And if it's not going to run on Hyper-V. It's not going to run on the competitive hypervisors either. VMware is also an x86, x64 hypervisor. So this is not some competitive disadvantage that Microsoft has. That's just the fundamentals of the chipset architecture. And so then the next question is, do I have integration services for that operating system? And so if I don't have integration services, then I'm going to be running on what we call the emulated devices. Hyper-V actually does a good job of emulating real physical hardware, particularly the NIC and the storage controllers. But if I don't have the integration services, then I'm running in this emulated mode, and it's frankly quite a bit slower. From a networking standpoint, I get megabits per second instead of gigabits per second in terms of throughput in the network. Basic CPU execution is going to be fine. Instruction sets are executing directly in hardware, and so CPU performance is going to be fine. But my disk I/O, my network I/O is going to be very limited if I'm running in that emulated mode. And I also don't get the advantage of the management integrations that we'll talk about. So that's sort of the yellow category of, yes, I can run it. We run Solaris x86 in our lab to do development work for System Center, for example, to make sure we can manage Solaris with System Center. But the performance is not that great. We do run it. It's helpful, but it's not something you'd probably do in a production workload. The green category, of course, is where I have integration services. I can take advantage of the synthetic devices that Hyper-V presents that are designed to get high performance in a virtualized environment. I get that full management integration. I get performance, frankly, that's near bare metal when running in a virtualized environment. And so Linux with integration services, FreeBSD with integration services. If you're running Windows as a guest on Hyper-V, there are Windows integration services there that are working with those synthetic devices and giving you that performance. So this is kind of the basic chart of what you can do, what you can expect in terms of operating systems running as a guest on Hyper-V, or frankly on any other hypervisor as well. And so the focus of the rest of this presentation is we're going to focus on the green box. We're going to focus on the integration services, the capabilities that you get there, because if you're running in any kind of real-world production environment, that's the box that you really need to be in. So a little more detail about integration services. So Hyper-V presents these synthetic devices, a synthetic NIC, a synthetic storage controller, to the guest OS. When the guest operating system runs, it sees these synthetic devices, and frankly, like any other device, it needs device drivers for that synthetic device. And so these are the integration services that Microsoft has been writing that are basically, when we talk about integration services, it's a set of device drivers for the guest operating system. They must be written for the OS because the device driver model is different in a Windows OS, in a Linux OS, in a FreeBSD OS, in Solaris x86, if that's what we were going to deal with. And so we have different implementations of these integration services for each operating system. We also, in addition to device drivers on Linux and FreeBSD, we have some daemon processes that run in user space. They coordinate with the device drivers, and they just do some of the utility functions that are helpful. And we'll see some of that in the demo coming up here. So when we talk about integration services, this is what we're talking about. This is what gets us into the green box on the previous chart so that we can get the best performance and the best management integration. In the Linux space, as we work with these device drivers, what do we do here? So we've got Microsoft developers writing the Linux integration services. We have Microsoft developers actually writing the FreeBSD integration services as well. There's a couple of different delivery models for these integration services. One is Microsoft actually packages a version of the Linux integration services. They're up on the Microsoft Download Center. As a customer, you can download those integration services, install them into your Linux instance that you've put on Hyper-V. The second device delivery model goes a broader path where we engage the Linux community. And so our developers actually submit Linux driver changes to the Linux kernel mailing list. The Linux community jumps in and says, no, well, you really should do it this way, or we're doing this work over here. We'd like you to integrate with that. We iterate, we take feedback, we make code changes. Eventually, the Linux community accepts the change, says, yep, you're good to go into the Linux kernel, and we bring those device drivers, the Linux integration services drivers, end up in the Linux main kernel. Linus Torvald maintains that, and so those changes actually go into that kernel. And then we work with the distro vendors, so the Red Hats, the SUSEs, the Canonicals of the world that are building these commercial Linux distros that you're the ones that are probably you're running in your production environment, and to get those integration services out of the Linux main kernel and actually packaged as part of the distro. So if you pick up Red Hat 7.0 or Red Hat 6.6 today and go install it on Hyper-V, the integration services are already there. They're built in. And so they're part of the Linux distro that you get from your distro vendor. And so we've got a set of distros that we work with to package the package the Linux integration services that way, and then have them effectively certified by the distro vendor. So in fact, if you have an issue with Red Hat running on Hyper-V, Red Hat stands behind that. You can take advantage of the support channels that you may have with Red Hat in order to get an issue dealt with. Now, if it's a problem with the LIS, if it's a problem with what the Microsoft developer wrote, it's going to eventually end up back in our chair to deal with. But you have the support relationship with Red Hat to make the right thing happen there and to get that problem solved. We're going to engage as part of the Linux community to get that solution put in place there. I've got a couple of slides now I want to go through to just look at sort of where we stand with the different distros. These are a little bit of an eye chart, and the important point is not all the individual details. But with Red Hat and CentOS, and in fact the Red Hat and CentOS charts are exactly the same because of course CentOS is derived from Red Hat. We've gone all the way back to Red Hat 5.5. We heard from customers that they're running older versions of Red Hat that are well out of support from the Red Hat standpoint, but they're still running those. And so we offer both distros that have the Linux integration services built in via that relationship with the distro vendor, as well as the LIS download from Microsoft. So both paths, in some sense, are available to you depending upon the distro. So if you're running one of the really old ones, yep, you can get the LIS 4.0 from Microsoft. You can install it. We've tested that. We'll stand behind you in running that older distro on Hyper-V. With some of the newer versions where LIS is built in, you can stick with the LIS that's built in, or you can, in fact, install the latest LIS 4.0. And same thing on the CentOS side. So we give you a choice there. The one thing to watch for from a Red Hat standpoint, what's certified is the version that has LIS built into it. That's what's gone through the Red Hat certification process that gives you the full support of your Red Hat subscription behind that. If you install LIS 4.0 into one of the supported Red Hat versions, that's not a configuration that has gotten Red Hat certification. So just be aware of that. But the changes that are in LS 4.0, if there's something, those are going to flow into the latest versions from Red Hat over time. That's something that we work with Red Hat on quite a bit to make sure that that happens. Let me mention LIS 4.0. So we've had LIS 3.5 that was out there for about a year and a half. We released LIS 4.0 on the Microsoft Download Center about 2 weeks ago, maybe a little bit less than that. So this supersedes the previous LIS 3.5 that you may have. And again, this is for use with RHEL and CentOS, and then for Oracle Linux with the Red Hat compatible kernel. And so LIS 3.5, you used to not be able to install it into a system that had LIS built in. That wasn't a supported combination. We've changed that with LIS 4.0. So if you think this is different than what you saw before, yes, it is different. So that if you want to, particularly on your CentOS, where you're not counting on commercial support, you can take LIS 4.0 and get up to the latest and greatest stuff there. And so you can install it into one that doesn't have any LIS in it. You can install it over LIS 3.5, or you can install it over one that has LIS built into it. So, why would you upgrade? We're continuing to make performance enhancements. The Azure guys in particular have been driving us on some performance issues. We've made some significant improvements over the last 6 months. And so all the bug fixes, all the latest performance enhancements are there in LIS 4.0. So that's what we're going to recommend there. The other thing that's going to be new, and I haven't written this specifically on the slide, is we're going to continue to update LIS 4.0 on a fairly regular basis, like every couple of months. So rather than go the year and 4 months or whatever that we went between LIS 3.5 and 4.0, we're going to put out updates every couple of months. We're going to do minor versions numbers for now. So what's up there now is 4.07. There might be a 4.08 out there in another couple of months. And maybe we'll bump to 4.1 if we've got significant new features. But performance improvements and bug fixes will go in as a 4.0.x release. So people ask, so how do I know when there's a new version out there? We do post an entry into the Virtualization blog, which is the blog for the Hyper-V team. We'll put a notice into the Linux and FreeBSD forum on TechNet as well to kind of keep you up to date when there's a new version of LIS that's available that you may want to upgrade to. So that's additional things that we'll do there. As we move on to just other distros for Ubuntu and SUSE Linux, there is no LIS 4.0. We're working entirely through the distro vendors to make these happen. And so, we go all the way back to 12.04. Ubuntu 15.04 has just come out. It's got the latest LIS there. And on the SUSE Linux, working with them on both the 11 SP series as well as the SLES 12 series. So that work is ongoing, and we keep those up to date. And as they put out service packs, SUSE puts out service packs, we'll put later versions of LIS into those service packs. Oracle Linux is an interesting one. Oracle Linux, of course, has two kernels, the Red Hat compatible kernel and the Unbreakable Enterprise kernel. On the Red Hat side, you'll get the same thing that you get in the Red Hat equivalent releases. And then we work with Oracle to get the latest LIS into those Unbreakable Enterprise kernel updates. And then Debian through 7.6, 7.7, and of course a couple of weeks ago Debian 8.0 came out. We've not yet had a chance to fully evaluate Debian 8, but we'll get that done shortly here and then have an update on full support in the Debian 8 release. Lastly, I'll mention FreeBSD. So FreeBSD 10 is where we have the BSD integration services built in. And we have some backports that are available for earlier versions of FreeBSD. So you can kind of see 10.0 had most of it in there. 10.1's even got the key value pair support. And we're continuing to do development work there. And Jason will give us an update here on the FreeBSD stuff toward the end of the session here. Documentation. So where do you keep track of all this stuff? So if you haven't found it yet, we've got an area on TechNet under the Hyper-V area where all the latest Linux and FreeBSD info is. And so, latest versions, we keep this documentation up to date. The 7.1 stuff's already been published, for example. This is a slightly old screenshot But these give you the feature grids, and we can run down the individual capabilities that you get, and you see check marks in some of the boxes, you see some notes in some of the boxes. This documentation is in the process of getting updated to have LIS 4.0 in there now as well. So 4.0 is out. This documentation page probably won't get updated until next week, but we'll have that information there. So this is the place to go for all the information about running Linux on Hyper-V. If you've got somebody who wants to see, is Microsoft real? Is this serious about this? There's other pages that talk about best practices and other notes that you need to know. So this is the key place to go for that. All right, let me shift gears a little bit, and we'll move now into some of the feature descriptions. Dynamic memory is one that we get a lot of questions about. I'm sorry, one other thing here. Operating Linux in FreeBSD. I'm off gears here a little bit. You're running Linux on Hyper-V, you're running FreeBSD on Hyper-V, you're running Windows on Hyper-V. How do you operate it? And there are a couple different ways. Obviously, you can use Hyper-V Manager. Hyper-V Manager works regardless of what the guest operating system is. Interestingly, you can also use PowerShell. So any of the PowerShell commandlets that you may be using to start VMs, stop VMs, create VMs in Hyper-V, that works regardless of whether the VM is running Linux as well. So you can do that from your Windows box and use PowerShell. Of course, System Center Virtual Machine Manager and the Azure Pack as a way for doing the private cloud. That all works with Linux. Earlier sessions have given you a view into that. And then, of course, the Azure public cloud is ultimately communicating with the Hyper-V host as well in order to operate those VMs. And so regardless of whether that VM is a Windows VM, Linux, FreeBSD, those mechanisms for doing the operations all work the same regardless of what the operating system is in the guest. All right, now we'll move into the feature area. Enhanced management. So you can do from Hyper-V, for example, you can say shutdown on a VM that's running Linux, just like you can on Windows. The Linux integration services ultimately gets poked, and the Linux integration services run the equivalent of the Linux shutdown command. There's time sync. So when you crank up a new Linux VM, it syncs the time within the guest with the time on the host, and then maintains that upon resume as well, if you were to pause and resume the VM. We do recommend that you run NTP in the Linux guest to keep the time correct over time. There's time slicing going on the hypervisor. It's a challenge to keep the time correct in the guest, and so NTP is the great way, and the way we recommend that you do that. On a Windows guest, of course, if it's domain joined, it's really continually syncing its time with AD. Not present there on the Linux side, and really the equivalent on Linux is to use NTP. Key value pairs, another great feature that allows you to communicate information back and forth between the guest and the host. And this is not a network connection. This is passing over what's called the VM bus, which is the internal communication path between the Hyper-V host and the guest. It allows you to pass information from the host into the guest. It allows you to pass information from the guest into the host. These are key value pairs. The name is a string. The value is a string. And we actually use this to pass basic information like the guest IP address. So the guest is going to come up. It's probably going to do DHCP. It's going to get an IP address. How can Hyper-V know what that IP address is? They may not even be on the same networks. The networks may be disjoint. And so the key value pair mechanism, for example, allows the guest to pass that IP address into Hyper-V, so that if you're looking at the Hyper-V console, you're looking in VMM, you can actually see what that IP address is that the guest has. And then other applications can use the APIs to pass information back and forth between the guest and the host. This does require that one of the user space daemon processes is running within the Linux guest. One of the things that we see sometimes is that daemon's not running, and the customer says, hey, I'm looking in the Hyper-V manager, I'm not seeing the IP address. If the IP address is blank, it's probably because the KVP daemon process is not running in the Linux guest. So that's the key troubleshooting point there. Other things that are basic features. Generation 2 virtual machines. This support is now present in most of the Linux distros, the later versions. Generation 2 VMs, if you remember, those are UEFI-based VMs. There's no BIOS there. The older Linux distros don't even support UEFI, so they won't run in a Generation 2 VM. But if you go to RHEL 7, if you go to SLES 12, the latest Ubuntu versions, they have the UEFI support. They're able to run in a Generation 2 VM. You can pixie boot for synthetic NIC, which is a really nice capability on the Generation 2 VMs. You do have to turn off secure boot. Hyper-V in 2012 R2, by default, when you create a Generation 2 VM, it has secure boot checkbox checked. And the Linux within Hyper-V 2012 R2 is not able to do secure boot. So that's what the next line is. In the 2016 version of Hyper-V, this is one of the new features where we do have the secure boot support for Linux VMs. So the Linux distro vendors have gotten their shim bootloaders signed with the right certificate that is now trusted by Hyper-V in the 2016 release, and this allows us to do secure boot with the latest versions of those distros. VHDX resize, being able to change the underlying size of your virtual hard disk. That is supported in 2012 R2. When you make you're in Hyper-V, you're using a PowerShell commandlet, or you're just going into the Hyper-V UI, Hyper-V Manager UI, changing the size of the VHDX, that's immediately visible to the Linux guest. You can then go into your Linux guest and expand your partitions, for example, expand your file system sizes to take advantage of the larger VHDX. You can actually shrink as well, as long as your file system and logical volume layout is prepared to handle that. So if you shrink your underlying virtual hard disk without making sure that your file systems are set up to deal with that, you can put yourself into a situation where you're corrupting your file system and your logical volume manager. So just be aware of that. I'm going to talk a little bit about dynamic memory. This is something that I get a lot of questions about. You know, how does this work in a Linux machine? Hyper-V manages the memory allocation if you check the box to enable dynamic memory. And it can add memory to a guest. It can remove memory from a guest. And basically, this lets you get higher VM density. You can overcommit the physical memory that you have on the Hyper-V host using this mechanism. Works for Windows guests, works for Linux guests. You can mix and match the guests on the same Hyper-V host. The dynamic memory algorithms are compatible with each other. And so Hyper-V could take memory away from a Windows guest, give it to the Linux guest, and vice versa if you're running a mixed combination on the same machine. There are basically two different mechanisms for implementing dynamic memory. And you've got to understand a little bit about what those mechanisms are and when they come into play. So there's the hot add mechanism. And that adds memory above what the initial startup memory size, up to the maximum. Now, we have hot add. There is no hot remove. And so hot add is increases the total memory size. The Linux guest knows that the memory size has increased, and it knows that it has more memory to play with, but there is no corresponding hot remove. The way that the remove is done is with something called ballooning. And this is actually the same as what happens on the Windows side of the world as well. But what ballooning does is it removes memory that is between the current size and the minimum memory. So it can take the memory down to the minimum, but it does it in a different way. Linux doesn't realize that the memory has actually been removed. Linux still thinks the memory is big, even though certain holes have been taken out. And so it treats the memory that's been removed as used buffers. And so let me take a picture here and kind of show how this works. You start up the Linux VM, and you have startup memory, and so the blue is what is allocated. That's what the Linux VM thinks it's got. If the memory demand goes up, Hyper-V may decide to add memory to the VM, and in that case, the hot add mechanism will kick in and increase the size of the memory. So Linux actually thinks it's got more physical memory to play with. And so the internal memory algorithms within Linux will do that. Now, if the memory demand goes back down at that point, ballooning may remove some memory. And basically, the device drivers within Linux, the Linux integration services, will grab some of the memory, tell Linux that it's allocated, and the device driver will give that physical memory back to the Hyper-V host. So the total size, the dark blue size, doesn't really change in terms of what Linux thinks is allocated, but some of it's been stolen and kind of given away in a hidden fashion. The amount that's taken will never take the total of the dark blue below the minimum memory. Got a question here?
Yeah, when you do a hot add again, does it fill those holes again?
Excuse me?
If you do a hot add.
Yeah, so if demand goes back up again, so here's what can happen. Right, the question is what happens when demand goes back up again? First thing that'll happen is we'll fill the holes back in again. And so maybe the demand goes up and one of those holes gets filled back in. Once all the holes get filled back in again, if demand continues to grow, then you may go back into a mode where you hot add and the dark blue side would go up. But as long as you're operating between the new, dark blue side and the minimum, the ballooning mechanism is what does all of that. So it's a little bit complicated, but it's interesting. It's important to understand this because of the way that it ends up showing up within the Linux guest operating system. And so if you take a look here, and I'll show a demo of this here in a minute. The bottom picture is showing what Hyper-V thinks is going on with the guest. And so you see that the startup memory was basically 1 gigabyte. The actual memory that's assigned in this picture is down to 600 and some odd megabytes. So Hyper-V has actually stolen some memory from the guest using the ballooning mechanism, and the amount actually allocated to the guest is less than that. Now, up in terms of what Linux sees, Linux is seeing 862 megabytes as being allocated. And so this is where the ballooning has kicked in and taken some memory that Linux doesn't really realize has been taken away. The total size that Linux sees is still the larger number there. And we'll look at that here in a demo in just a second. So a couple of other notes about this. This makes sense when the memory that the VM requires sort of varies in time. When the workload varies, and it actually makes sense to vary the amount of memory that's assigned. There's some situations, particularly if you're running Oracle database, some of the Java app servers, they do their best to kind of take control of the memory. They don't even want the operating system to be doing memory management. And in those situations, you really don't want to be using dynamic memory because you're going to end up fighting between Oracle trying to manage the buffers, Oracle database trying to manage the buffers, and Hyper-V trying to steal some memory away. Bad things are going to happen in that place. So you really want to not try to do dynamic memory when you've got one of the apps that's trying to take over the machine and do all the memory management for you. Some of the older distros, it's also important to recognize, do not have the hot add function. You can see that on the TechNet webpage. And so in that case, you want to set the startup memory to the maximum memory and just let the ballooning function do its thing to shrink and to grow the memory as need be. So a little bit of a workaround there if you're willing to set the startup memory up to the maximum memory there. All right, one more feature I want to talk about is live virtual machine backup. This is the ability to back up a virtual machine running Linux and do a live backup. You don't have to pause or stop and then restart the virtual machine in order to do the backup. The backup is file system consistent. So we've rigged it up with the Linux integration services, and I'll show a diagram here momentarily, to get the buffers, the file system buffers that are in the Linux OS flushed out to the virtual hard disk. And then make a shadow copy of the virtual hard disk and then back up that shadow copy so that you get a file system consistent backup. And frankly, for most applications, that's sufficient. Linux is very much file system oriented, and so if you're able to get a file system consistent backup, that'll handle a lot of the cases. And so in some ways, it kind of plays the same role as VSS does on a Windows machine. Not quite as sophisticated, but the Linux apps tend to be file system based anyway, so it gets you a lot of the way there. So how does this work? So we've got a Hyper-V host. I've got a Linux guest. I'm showing user space and kernel space in that Linux guest. I've got some file system buffers in the kernel. And I've got a backup utility. This works with, I'm going to show a demo with Windows Server Backup, works with DPM, works with third-party backup tools that know how to back up Hyper-V. But basically, the utility tells, hey, Hyper-V, I want to do a backup on that VM. Hyper-V then, through the driver that's part of the Linux integration services, signals up to this VSS daemon process, and the daemon process starts these backup steps. And the daemon tells the kernel to flush the buffers, so the buffers get pushed back down to the VHD or VHDX that's in the Hyper-V storage. The file system is frozen momentarily, and this typically happens in a second or two or less. And then the Hyper-V creates a VM checkpoint and then tells LIS to unfreeze the file system. So you get this very short window where things are frozen between step 3 and step 4 while the buffers are being flushed. Now that the VHD on the disk is consistent, we take a snapshot of that VHD, and then we actually do the backup from that snapshot. So the backup process will continue to run. Meanwhile, the Linux virtual machine is continued to run your apps. Your network connections are not disturbed. From an in-service standpoint, you just really don't see much of an interruption at all. This does depend upon again, one of these daemon processes, the VSSD process. So you got to make sure that that's running. There have been some bugs in the backup stuff that have gotten fixed. They're fixed in LIS 4.0, the latest Linux distro. There is this Linux kernel bug that prevents ext2 file systems from being backed up properly. This was causing a problem on backing up Ubuntu's. This has also gotten fixed recently as well. So there have been a couple of things along the way that we've gotten fixed. I think we're in pretty solid shape now in terms of the virtual machine backup capability. All right, one more. Let's move over and talk about networking here. One of the new features in 2016 is the ability to hot add and hot remove virtual NICs. So this gives you a great capability. You added virtual NIC into the virtual machine, and it automatically shows up in Linux. And I'll do a demo here and see how that works. You go into Hyper-V and remove the vNIC, and then magically it disappears from Linux. So we've gotten the coordination in place with the Linux kernel to know that that's happening. The other big thing is network throughput. So we now have full implementation of VRSS, full implementation of several of the TCP offloads, and this has given us the ability to really drive 10 gigabit Ethernet to full capacity. So our typical test scenario is I got 2 Hyper-V hosts, I got a 10 gigabit physical link between the two, I got Linux guests on each Hyper-V host. What kind of throughput can I get between those Linux guests in that configuration? And at this point, we use iPerf3 as a perf test, and we're seeing about 9.4 gigabits per second. So we're maxing out that pipe. Next step is to change the physical pipe up to 40 gig Ethernet, and at this point, we're seeing about 26 gigabits per second on a 40 gig physical pipe. So that's good. It's not where we want to be. We want to get up into 30-something odd gigabits per second on a 40 gig pipe. But this gets back to that fundamental thing of we want to be able to drive these guest VMs. They want to be able to drive the hardware, get the performance, frankly, that's very close to being on bare metal, even though you're virtualized here. And so this is a continued effort in progress here, but we're feeling pretty good now about getting the 9.4 gigabits per second out of the link there. All right, let me shift over and do a demo, and hopefully the connections are still live here. Oh man, my VPN connection got terminated. All right, give me just 1 second here for this. Hopefully this to come back alive. This demo is running on a machine back in my office in Redmond, and all right, we seem to be connected again, and let's see if I can get this connection made. All right, we're back again now. I'll shift over here. So I'm running on a version of Windows Server Technical Preview 2 because I want to be able to show a couple of the new features, including the hot add and remove of a virtual NIC. I've got Hyper-V Manager running here. Let's take a look at this particular virtual machine. This is one that I have dynamic memory enabled on. So you can see it was started up with 768 megabytes of memory. The currently assigned memory is down to 698. So Hyper-V, while it was kind of sitting idle, Hyper-V stole a little bit of memory from it via the ballooning method. And if I go into this virtual machine itself and we take a look at what's going on, I'm going to do a watch free-m command. And you see that the Linux machine sees 736 megabytes of memory. There's actually 32 megs of difference between what Hyper-V sees and what he sees in terms of the 768. I think that 32 meg is allocated to the frame buffer, so there's always this 32 meg offset there. Now what I'm going to do is create some, let me bring up my PowerShell. I'm going to create some load on this virtual machine here. And so I've got a PowerShell script that's just part of the demo setup here that's going to generate some load on that virtual machine. And so this will be hopefully cranking up here in the background. And we start to see the CPU utilization go up. You can see the assigned memory has now gone up. We're hitting 1092 megabytes. And actually up in the Linux VM with the free-m command, you can see that the size of the memory has gone up. So hot add has kicked in here, has added some memory to that virtual machine. This typically pushes it up to about 1,200 megabytes needed. We'll see how high that goes up there. And so we can see also, as you look at the used and free memory within the Linux virtual machine, it's added some more memory back to it, so the free went up, but the free is starting to go down. The used is going up as the memory pressure and the demand on the memory from that machine goes up. Now, if we kill off this load here, terminate that, we will start to see the free memory in the Linux machine go back up again, 648, 649, etc. And if we wait a little while, we'll actually see the assigned memory to this virtual machine go down. And so I'm going to step away from this demo momentarily, take a look at a couple of other things, and we'll come back and see how the ballooning process has taken the assigned memory down. Remember, in the Linux machine, we still have 1,168 megabytes allocated. Because the ballooning process doesn't change that, that number is not going to change as we go forward here. All right, let's take a look at, here's a virtual machine that is, get my settings here. This is a virtual machine that's in a Generation 2 VM, and this virtual machine is configured for secure boot. The checkbox is on right here. If I boot this virtual machine, we will see that it actually does boot, and that is the new feature of Windows Server 2016 that allows you to do that secure boot. A couple of typical errors as Linux boots up here. In a Generation 2 VM, there is no 8042 controller for the keyboard. The keyboard has a virtual device driver, so that's why you get that error. And we're up and running and able to log into that virtual machine. So demonstrates that that works. Let's see, what's this guy doing these days? He's still at 1,200 megs. All right, we'll come back to him in a minute. The other thing I want to demonstrate, let's show backup. I've got a machine here, and we're going to connect to him. If I grep, you'll see that this guy is running the two daemon processes. He's got the VSS daemon, the KVP daemon. I'm in the var log folder. I'm going to create a workload on here. While true, while true, do cat messages done. So this is just going to create a whole bunch of, you can see that the VM's actually doing something. If I now go down to the backup utility, I'm going to run Windows Backup here. I'm going to start a local backup. Get this guy going. I'm going to do a backup once. We're going to back up do a custom backup on this Hyper-V host. We're going to add an item. And this particular virtual machine, CentOS 7, is online. So this is an online backup of that virtual machine. We do next. And we're going to do this to our local folder where I've got some disk space here. And we're actually going to start a backup. And if we bring up Hyper-V Manager, we can kind of see put that on top of this here. We will See, the VM is continuing to run in the background. We will see us get into a backup state here momentarily with the backup tool. And that may be the pause there where it's flushing buffers. We're now in the backing up state. So you just saw a brief hitch there in the output, and we're able to get the backup underway here. Oh, backup not started. Something happened here. Oh, it's not started. It'll finish here. It'll get going here. Initializing application backup. Backup in progress. We're at 0 KB out of. So this will run and do the backup there. I'm actually going to cancel out of this just to save the load on the system here. So that shows you the live backup of this particular Linux VM. All right, we're going to look at one more thing here. Let's go take a look at a virtual machine here, Generation 2 virtual machine, and get the console up. Let's take a look at this guy. If we look at the networking configuration on this machine, he's got an ETH0 and he's got a loop back. So what you'd expect to find on a typical Linux VM with a single NIC in it. And in fact, if we look at this VM in the settings, we see that we have one network adapter. But I'm going to add a new network adapter to this machine. Click the Add button. We're going to map this one through to the physical NIC, just like the other one, and click OK on this. And so I've now added a second NIC to this virtual machine. And in fact, if I run ifconfig again, let me clear so we're at the top of the screen. You'll see we now have two NICs, ETH0, ETH1. IP address has been assigned to both of them. DHCP is kicked in and assigned an IP address, and we now have two NICs. And I could actually putty into that IP address and connect to the VM there. And similarly, we can go back to Hyper-V Manager and open up the settings again. I can pick this network adapter, say remove. Take it away. Yes, this may disrupt connectivity. We understand that. And then if I do ifconfig again, we'll see that we're back down to the single Ethernet controller. So that gives you a view of the ability to do hot add and remove of NICs. This only works with Generation 2 VMs, and this is one of the features that requires Windows Server 2016. So just to be clear, this is one of the new features. All right. Let's do one final check. I want to go back and look at this guy and see what's happened down to. So the assigned memory, wrong VM here. We can see now that the assigned memory has gone back down to 786. Again, the load on that disappeared. We went down from 1200 down to 786. But if we look in the VM itself, we still see that the total allocated from the Linux standpoint is still the 1168. So that's where the ballooning has kicked in and stolen some memory from it. All right, we'll flip back now to a couple of more slides and kind of wrap some things up here before I turn it over to Jason. Some tips and tricks. If you're using high availability configurations, you've got a Hyper-V cluster, and you're doing live migration of VMs around the Hyper-V cluster, you do have to assign a static MAC address to your network adapters for your Linux VMs. When you live migrate and you get a new MAC address, Linux thinks you've got a different network adapter. And so it creates a new network adapter, and your network configuration ends up not being associated with the correct network adapter. So this is documented on the TechNet webpage of the best practices, so something to be aware of. The other thing about the scheduler, this is something that's probably good practice on most any hypervisor situation. Linux has different disk I/O schedulers. They try to make knowledge of the cylinder and track and sector structure of the hard drive. You know, back in the day when you ran on physical disk and it really mattered. Today with SSDs, today with virtualization, set the scheduler to no op. It turns out that it actually can make a significant difference in your disk I/O performance if you don't have the Linux disk I/O scheduler fighting with the Hyper-V disk I/O scheduler in terms of what they're trying to accomplish. And then finally, I mentioned a couple of places. You got to make sure you got the daemon processes installed and running. Some of the Linux distros don't have those daemon processes enabled by default, so check to make sure they're in there, and if need be, add those and make sure that they get scheduled to run as part of the boot up process. Systemd or whatever it is that your init mechanism is used on that particular distro. Finally, couple of things, Linux LIS versions. You do get this warning in Hyper-V, actually an error in the error log about version mismatch. Ignore this. We've got a KB article out there. This is something that's been fixed in Windows Server 2016. It's a fix that had to go into the Hyper-V side, so it's not something we could have fixed on the Linux side of the world. I get this question with some frequency, just reminding people you can ignore this particular error about being in an unsupported configuration. LIS version numbers. What version do I have? A couple of different things here. There's no single answer. It's this collection of device drivers. If you have a built-in LIS, and if you run lsmod or modinfo to see what version of these kernel modules do you have, you're going to see a 3.1. Don't try to compare that number with the 3.5 or the 4.0. That's the number that's stored in the upstream Linux kernel. We don't try to go update that number because that would create a bunch of churn in the Linux kernel. And so you're going to see 3.1 in those drivers, even though there may have been some updates done there. If you have installed the LIS 3.5 or 4.0, you can use the RPM command, grep for Hyper-V. You're going to get a package number back there, and then you'll see the version number in that string there. So 4.0.7 is, in fact, the very latest and greatest version of LIS if you have installed it. And we did fix the kernel modules in LIS 4.0 to report their version as 4.0. So it's another question I've gotten a couple of times down on the show floor here while we're here. LIS source code, last thing. So if you're one of those guys who likes to play with the Linux kernel, you want to get the latest and greatest code, you build your own Linux kernels, it's up there. The source code is also part of the LIS 4.0 package. So you can get it from the GitHub repository. You can go to the Linux main kernel. There's a number of files and directories where the Hyper-V driver code, I've just kind of listed some of that stuff there for your information for reference purposes if you want to go find the LIS code that's up there. So that's the quick summary on the Linux side. Jason, Microsoft loves FreeBSD as well.
Thank you, Michael.
Do a quick summary here.
All right. So FreeBSD. So first of all, a quick FreeBSD 101 background for folks that may not be familiar. FreeBSD is not a Linux-based operating system. It actually originates from a very old version of AT&T Unix that Berkeley Software went ahead and kind of borrowed from, built upon, and once they wanted to get that out and release it in broad sense, there were some issues because they had to get licensed from AT&T, so eventually they replaced all of the AT&T Unix aspects and then made BSD in a sense. So it's very Linux-like, but it's not Linux, right? So just bear that in mind for those that are not familiar with FreeBSD. But let's talk about why Microsoft cares about FreeBSD, because typically you don't think of FreeBSD as a general purpose operating system, at least in an enterprise sense. But there are a couple of key reasons why we care about FreeBSD, and there's probably reasons that you might care about FreeBSD as well in your enterprise that you may not even be aware of. So the first is that FreeBSD tends to be a common operating system for many appliances, such as storage appliances, network appliances, and security appliances like routers and firewalls and just storage devices in general. And there's a couple of reasons for that. Number one, BSD is a very stable, performant operating system. The community that's behind the product, behind the FreeBSD Foundation, is a relatively small community. They don't churn the OS very often, so it tends to be seen as stable. and is also tuned very well on the networking side and the storage side. So that's one reason. The other reason why appliance vendors really like BSD has to do with the licensing. It is not a GPL copyleft licensed OS like all the Linux variants are. It is actually a much more permissive license that allows the appliance vendors to effectively take the source and go ahead and modify it to their needs, and then not have to upstream that back into the community. So they're able to effectively create their IP and their networking stack, right, for a network appliance. And the same on the storage side. Allows them to compete. So having said that, just like servers, and we're seeing VM density increase more and more and more over time, the same thing is happening on the hardware side for hardware appliances. What's effectively happening is you're starting to see more startup companies that are doing storage-based appliances, as an example, that are even skipping the hardware and going direct virtual. And they're able to then compete on price. Granted, they probably don't have as high of performant of an appliance, but they can still provide a lot of value. And certainly this is true on the networking side. So what we're starting to see is that all appliance vendors are starting to move to a virtual model to compete from that perspective. But also, as they think about how they can extend their business into the cloud, they obviously have to be virtual to do that. So we're seeing this increase heavily. So that virtualization aspect is big. As you can see from the graph, as an example, application delivery controllers, which are basically network appliances, the growth in 2014 of physical appliances was only 16%, whereas on the virtual side, it grew 88%. And we see the same thing across other types of network appliances as well as storage. The trend is very clearly there. They're going virtual. So from Microsoft's standpoint, because of that virtualization trend, we want to make sure we have rich Hyper-V support, just like we do for Linux, to support that model and to ensure that enterprises can then bring over those appliances into their data center and be able to run them on Hyper-V as they wish. And then really, as they think about extending to the cloud, whether either provisioning a VM directly from Azure, that's a virtual appliance, or migrating one with licensability, being able to support those appliances in Azure. And since Azure, the Fabric OS itself runs effectively on the same hypervisor that we have for Windows Server, that Hyper-V compatibility is there. So those two key things are important for Microsoft to ensure that we have a rich ecosystem, both on the private and public cloud. So the development model for BSD is very similar to what Michael talked about on the Linux side, but it actually is different in a couple of key areas that I'll walk through. So the same deal, you've got Microsoft developers that are writing BSD integration services. We bring those into the community. We actually, our lead developer on the BSD team is actually a committer to the FreeBSD kernel. So he has the ability to commit those changes, but still needs to go through community review. So he brings those up to the FreeBSD Foundation. They go through rounds of review. It's included in the FreeBSD OS, and then it's brought down to the customer, which in many cases, as I said, is an appliance or could be a standard server. Now, what's different here than Linux is it's not going into a kernel main because there is no kernel main for FreeBSD. FreeBSD is different than Linux in the sense that the FreeBSD Foundation actually maintains an entire operating system, not just a kernel. There's drivers, there's applications, and so on for an entire OS. So actually, when we get those changes, and from our perspective, which are drivers, committed into the operating system, they're actually a part of the next OS release for FreeBSD. So that leads to the question, what do I do if I want to take some of the investments that Microsoft's made for Hyper-V on an older version of FreeBSD? So what you can do is you can actually get ports directly or the source code directly and port those drivers back if you want to run on an older version of FreeBSD like 6.x, 7.x, and so forth. And we've done some work with some partners to actually make some of that happen, but that's effectively the model in terms of how it works. Either you get the operating system or you can get the ports for older versions. From a support standpoint, it's a little bit different. Any support for Hyper-V related issues on FreeBSD go directly to the FreeBSD Foundation. Now granted, our lead developer is a committer in the FreeBSD Foundation. That email alias effectively goes to him. So you're effectively talking to Microsoft. So if you do have issues, that's where you go. Now, having said that, it kind of ties into the support piece. We've actually been doing FreeBSD integration services for a while. And don't get confused, I'm going to say FreeBSD integration services 1.0, 2.0. It's not the same as Linux integration services from a versioning standpoint. We really don't have versions of integration services for BSD because they're incorporated directly into the operating system. There's no package that you download and install. So really, if you think about the versions here, they're more phases of work that we have done to enable functionality that I'll walk into. So the first set here of 1.0, which we did, gosh, what was it, about 2-3 years ago, Michael, at the first set of services were out, something like that. The work that was done initially was really very base work to ensure that we could get FreeBSD provisioned on Hyper-V and actually run it. And it worked. What didn't work so well is we hadn't done the optimizations around the networking stack, the storage stack, or even really from a scalability and a stability standpoint all up. And as such, we didn't really have a strong support story, so we didn't officially support FreeBSD on Hyper-V, meaning if you called Microsoft support, they would do their best, but most of the time the answer was, well, gee, that's just not implemented or it's not ready. Now, in the last year, a little over a year and almost a year and a half, we've made some significant investments into our integration services, primarily to support some virtual appliance vendors that we've been working with. The first set, which we have upstreamed or incorporated into 10.1, 10.2 and above, basically focus 2 areas. The first is a set of core areas that are necessary to enable the vertical scenarios that we want, basically networking and storage. But the first round was on the core and storage. So on the core side, one of the key things that we did is we implemented key value pair as a direct basically integration of the operating system. Prior to 10.1, it was available as a port that you had to bring in yourself. So we did some optimization of the KVP code to make it a little bit more resilient, but then we incorporated it natively. The big investment we made was really around VM bus. So again, VM bus is effectively the bus communication between the host and the guest, and we were very limited up until this point in terms of what device drivers could do in the VM bus in terms of communicating and having bandwidth. So the way it was architected, or the implementation prior, was that a device driver could effectively have a single channel and be able to bind only to vCPU 0. So even if you had 5 or 8 CPUs in your VM, it didn't matter. You were stuck on vCPU 0. So we enabled what's called multi-channel, which effectively breaks that barrier. We also did some signal optimization to optimize the number of interrupts for reads and writes all up. And then on the storage side, we did a couple of key things. The first one is we enabled subchannel, which takes advantage of the multi-queue support that I just talked about. So effectively now, the storage stack will allow you to not only have multiple channels, but to be able to scale those on multiple CPUs if you have more than 5 eCPUs. So significantly increases throughput. So we went from being around, I think it was 300 or 400 IOPS to around 4,000 to 5,000 IOPS. So significant increase in the storage side. As you can see, the numbers indicate what versions they're available in. Effectively 10.2 and above for the core and the storage stuff, and KVP again is available in 10.1. Now what we're working on now is really enabling the networking scenario. So there's a couple of key areas that we focused on there. The first one, and Michael just talked about this as well, on the Linux side, we can't take that work and port it directly because FreeBSD is different enough we have to redo that work, but we're trying to bring it in at around the same time. The first is TCP segment offload, which offloads the checksum and segmentation workloads effectively from the CPU and puts it on the virtual NIC or the virtual switch. And then another feature that we implemented that's more specific to BSD, which has been ported to Linux, is called CARP. CARP is the Common Address Redundancy Protocol. Effectively, what CARP allows you to do is to have multiple guests be able to be assigned to one IP address and a single virtual host ID. So typically, it's there for resiliency reasons and load balancing reasons, but it's something that's been highly desired by networking appliance vendors. We did, on the storage side, we enabled hot add SCSI. add and remove SCSI. And then on the networking side, we did some more stuff. We did VRSS. So VRSS basically spreads the networking load across multiple CPUs. And we did multi-queue, which takes advantage of the multi-channel support in VM bus and support for live virtual machine backup. So we're going to continue to iterate on BSD integration services, but again, really focused on enabling those appliance scenarios on the private cloud and the public cloud going forward. Now, Michael talked about FreeBSD, or talked about overall that the session is really focused on Hyper-V, but I do want to talk really briefly about Azure, because at the end of the day, really where we're going to see a groundswell of this work is really going into Azure. So I wanted to talk very briefly about FreeBSD in Azure. There's basically a few ways you can get FreeBSD in Azure. One way is to go into the marketplace and to bring in a virtual appliance. And I'm happy to announce that as of this week, Citrix will make their NetScaler VPX available in the Azure marketplace. So you should see that going live in the next few days. It's the first FreeBSD-based virtual appliance that's available in the marketplace. The next way to do it is to basically bring your own VM into Azure. Okay? This would allow you to, or would require you to effectively take your VM and prep it for Azure, upload it to your storage account, and provision and run it. It takes a little bit of work, but it's certainly possible to do, and folks have done it. A little bit easier way to do it is to go to our VM Depot website, which is managed by our OpenTech group at Microsoft. This is basically a website where the open source community submits in various different VM stacks that they've created. And from there, you can actually provision a FreeBSD 10.1 VM that's actually submitted by the FreeBSD Foundation, and you can provision it directly into Azure if you want. So that's the quick summary on the FreeBSD side. I'm going to turn it back over to Michael, who will wrap things up.
So I think, let's see here. Yeah, so summary, we want to convey the message that we're committed to your heterogeneous data center. Run Windows, run Linux, run FreeBSD. And frankly, they're working great. I've heard a couple of stories just here at the conference of people who had previously been running their Linux VMs on other hypervisors in other clouds, had moved them over to Hyper-V, had moved them over to Azure, and saw performance increases. So we were very pleased to hear those kinds of things. So I think, it's real, it's robust, people are using it today, it's good stuff. So Microsoft loves Linux, Microsoft loves FreeBSD as well. So that's the quick summary of what we've got here. Remember to fill out a eval form. We really do pay attention to what those things say for this session, for any of the sessions that you've been in. We'd appreciate you doing that. And we do have some T-shirts. Anurag, if anybody wants to stick around, and you've got your trivia question here you want to present?
Yes, I do. So, but who here is interested in winning a Microsoft Linux T-shirt?
Got a few takers?
Okay. So we got 3. So we're giving away 3 T-shirts. First question out of you 3. Is AIX PowerPC supported on Hyper-V? I don't know. Okay, secondly, what does BSD stand for? Okay, same time again. Lastly, name one feature that's only available in Windows Server 2016 for Hyper-V. Okay. I think we got 3 T-shirt winners. Yeah, there we go. Okay.
All right. Thank you, guys.